Okay, so how would we actually approach solving a question like this? Now again, like I said earlier, we can't integrate it this way because e to the minus x squared is impossible to integrate by hand, by using our elementary, quote-unquote, elementary techniques from Calc 2 or Calc 1. So we have to change the order of integration. This way it's impossible. Now how do you do that? Well, let's first draw our region and see if we can sort of change our perspectives a bit. So notice that x is going from 1 to y over 2, and y is bouncing between 0 and 2. Okay, so let's draw that. Okay, so notice x equal to 1. Remember, that's going to be a vertical line through x equal to 1. Okay, so that's that upper bound there. Y over 2, so if we set x equal to y over 2, this is just the line y equals 2x. Okay, so that'll be this line right here. Okay, and now notice that we have y is going from 0 to 2. Okay, and again, x is bouncing between this bottom line here all the way up to this top line here. So the region we're looking at is this, another triangular shaped region. Okay. And notice here that this point, just for your reference, is 1, 2. Okay, so if we want to change the order of integration, again, we're going to have to parameterize this. And we're going to parameterize this by, again, sort of shifting our perspective. Instead of y going from 0 to 2 like we have here, what is x going from? X, you can think about this as x going from 0 to 1. Okay? And if we take a slice along the x-axis, like this, y is bouncing between this function, which we already said was y equals 2x, and the x-axis 0. Let me write that down. Y is going from 0, the x-axis, to 2x, and at the same time, x is bouncing between the numbers 1 and 0. Okay, so this integral here will become the integral from 0 to 1, that's what x is going from. Integral from 0 to 2x, that's what y is going from. E to the minus x squared dy dx. Boom, now that's something we can integrate, so let's integrate that. So if we integrate this with respect to y, we're just going to get the integral from 1 to 0 of y e to the minus x squared dx. Okay, whoops. Evaluated at 2x and 0. Okay, so if we plug that in, we'll get integral from, I already forgot, integral from 0 to 1, 2x e to the minus x squared dx. And now using u substitution, we can get that. So let's let u be x squared, du is 2x dx. This will become the integral from, let's see, and it'll still be 0 to 1, e to the minus u du, which is just e to the minus u, evaluated at 1 and 0, which is going to be e to the minus 1, minus 1. And so we get 1 over e minus 1. And there you have it. So that would be the double integral in this case. Okay? So keep that in mind. If you're computing a double integral, first think about order. Okay? If I give you a double integral like this, is it better to integrate with respect to x first and then y, or y first then x? And again, that kind of depends on what functions you're dealing with. Okay? Now, if you choose to change the order of integration, that means you have to reparameterize. So figure out what the other variable's doing and how you can bounce it between two functions and so on and so forth.